Belting made easy.
A corrugator is a large production line composed of several smaller machines working together. Its purpose is to combine two types of paper to create a sheet of corrugated fiberboard and have that sheet trimmed, slit, and scored per the customer specifications. Corrugated fiberboard consists of multiple layers of paper, the flat outer layers known as liners, and the wavy inner layer called the corrugated medium or just medium. The medium is bonded to the liners using an adhesive, with starch being the most commonly used type. There are several types of corrugated board products. Single face, one layer of corrugated medium glued to a single flat liner. Single wall or double face, one corrugated medium sandwiched between two flat liners. Double wall, two layers of corrugated medium glued between three liners. Triple wall, three layers of corrugated medium bonded to four liners. Each structure offers different levels of strength and durability depending on the application. In this video, we'll show you how a double wall is made. Corrugator line has two main parts, a wet end and a dry end. The wet end is where the medium is fluted and glued to the liners and cured. The dry end is where the final board is scored, slit, trimmed, cut, and stacked. The process begins with paper rolls feeding into the single facer machine by modular belts. On the left, we have the roll stand for the liner, and on the right, the roll stand for the medium. Both stands have the roll being used plus a secondary roll to be spliced when needed to provide a non-stop operation. The medium has to be heated with steam before being corrugated so it doesn't break. It first goes through a steam-heated drum called the preheater and a few steam showers to make the fibers soft and pliable. Then it travels through the corrugated nip between the corrugated rolls. The corrugated roll shave ridges and grooves that mesh together to form the flutes in the medium. Then the medium gets pressed against the top corrugated roll while another roll applies the glue to the top of the flute. The glue roll picks up adhesive from a pan below, and a metering roll or doctor roll adjusts the thickness of glue. Then the glue roll moves in opposite direction and slower than the pressure roll to create a whipping action. The speed also is used to adjust the amount of glue used. The liner, coming from the opposite side, is also preheated on a steam drum to prepare it for bonding. Then they both get into contact in what is called the single-facing nip between a pressure roll and the top corrugated roll. Heat and pressure make the line and the medium bond. Sometimes the pressure roll is substituted by a pressure belt. The pressure belt is usually a felt belt made of different natural and synthetic fibers resistant to heat and moisture. The pressured belt increases the time on the nip and eliminates pressure marks, but reduces the pressure itself, so it is used for lightweight boxes with high graphic demands. Some belts wrap the fluted medium and pull it up an incline called the rise onto the bridge. Once on the bridge, either a wide bridge belt or several narrow ones moving at a slower speed than the rise belts create some loops called festoons. These loops allow for the storage of fluted liner in a shorter space. The belts on the rise to the bridge and on the bridge itself are usually a black polyester, felt such as Novo felt, or solid woven cotton belts. This is because the belt must be able to withstand some heat and moisture. Both fluted liners and the bottom liner all need to be heated, so they go through some preheated rolls. After being preheated, they go through the double gluer where the bottom of both fluted liners gets glued. The double facer gluer works with the same principles as the single-facer gluer. The bottom liner's continuous underneath. Now, the 3 layers go into the hot plate section. In this section, both fluted liners and the bottom liner get in contact. The hot plate section applies heat and pressure to remove any moisture and to get the 3 layers to bond and the glue to cure. This is done by 2 specialty belts sandwiching the double-wall cardboard overcast iron steam heated plates. The belts used on the hot plate are normally made of a combination of natural fibers, like cotton, to absorb the moisture, with some synthetic fibers like aramid and polyester to add heat resistance and avoid elongation while putting pressure onto the cardboard. At the end of the hot plate, we have the traction section where the cardboard cools down and gets in the right position for the dry end. It also helps maintain the right tension through the hot plate. Normally, a cotton or felt belt is used on this section. The rotary shear is used to cut off scrap during startup or order changes. The board moves to the slitter scorer machine. Normally, narrow belts in parallel are used to move the board. The belts usually have an abrasion-resistant cover, such as an elastomer, and a profile like rough top to increase the grip. The machine then provides any slit, trim, or score to the board. Trims are the cuts that remove the edges, usually a lower quality. Slits allow to cut the board to the desired widths, while scores are indentations that make it easier to fold the board later. The verted machine is used to create 2 levels that allow for faster processing and stacking. The final shear is used to cut the continuous web into individual boards. Narrow belts, normally with rough covers for grip and abrasion-resistant materials, are used for the infeed and outfeed of these machines, and move them to the stacker. At the stacker area, they get stacked carefully on top of each other. A platform lowers the stack as it gets taller until it reaches the desired height, and it gets moved to the packaging area. Beyond boxes, corrugated board is shaping the future of sustainable packaging, replacing plastics with eco-friendly alternatives. And with every innovation, our conveyor belts evolve to keep production moving seamlessly.